Yeah, the meeting has started now, and let me just share my screen. Yeah, I just hope my screen is visible. I
Yep.
was just seeing the meet invite and got to know the agenda of this meeting, and it was so apt that I took a screenshot of it and have put in here. It says training on multi-tenancy architecture and functionality in a product. Each word in this agenda means something and means a lot to every software developer. And I didn't give this agenda to like Stephen or Jyoti. I just don't know who kept this, but this is so apt for this meeting. So we will start with dissecting each and every word of what does this agenda refers to and what can we do on this meeting to understand what this whole architecture and this whole big words actually mean. Okay, so I will try to keep both English to make it more understandable to everyone. Let's see. So let's start with the word multi-tenancy. Before that, what word comes is tenant. Okay, I searched it on Google and it says tenant, a person who occupies land or property rented from a landlord. So, like in layman terms, tenant means someone who has rented something. Like if I'm living on a rent at a home, so I'm the tenant of that house. Okay, so this tenant word is like a layman word for renting something. So how is that so much relevant to software industry today? Why such word came into the software presence is what I was thinking before starting the session. For that, what I did was I researched upon what software evaluation has come over the period. So the software development started in 1950s, right? And after that there has been a tremendous development across all verticals of software industry. So just going in history, we saw that the softwares before were created in such a way that suppose there was a very big organization like NASA, say Bank of America, say Government of America, Government of India, which have to do something related to software. So what they do is to that either they have their own in-house team of very few software developers, or they used to collaborate with companies like IBM. Okay, and these companies like prominent software companies used to deliver software to them. So those software were proprietary softwares. They were developed for a particular use case and they belong to the company for which it was being developed to. And that piece of software cannot be used for other companies. Okay, that was the whole motto of that industry belonging to. And there was proprietary software development, and each piece of code was developed and shipped to a particular very big organization. But yeah, then after the evaluation started, we saw lots and lots of small companies coming up in software development perspective. Lots of companies getting interested in getting digitalized at every step. So they wanted more and more softwares to come up in the system, and more software development companies got existed in the early 2000s, 2010s. We see lots and lots of software coming up, companies coming up. So what these software companies used to do was that they used to create a software and say that very small company, say XYZ company in America, they used to sell that software to that company. And with the same requirements, suppose ABC company called them, they used to ship the same software with slight modifications to them. Okay, so they in the process they realized, okay, the same software is working for multiple companies with a subtle number of, what I say, customizations for each company. So this led to coming up a business idea of SaaS, in which few smart players in the industry realized very early that why not I develop this software, host this software myself, and provide services to other company. So this turned out to be what we call SaaS today, software as a service. So if I'm developing the software, I'm hosting the software, what would be the business model to charge for the other companies to use that software? Obviously, it would be renting. So here comes the word renting, and here comes the word tenant, which got associated with it. So that's why multi-tenancy came into picture a lot more prominently when SaaS as a software as a service got boomed up, and all companies took this business model, took this recurring business payment model, and developed softwares with that approach of developing a software, hosting it selfly, and providing services to a different company. with this doing renting to other companies and renting to other users. So here comes the concept of tenant. I hope that the word tenant, why it's relevant to software industry, is, you know, is clear to all.
Yes.
Yeah.
Yes, Raj.
So, so tenant, from that we move to multi-tenancy, and it gives a lot more hefty definition, saying is a reference for mode of operation of software, independent instances, multiple operations, applications, logically isolated but physically integrated. Okay, so we will dissect this glossary as well, which have been given by Google to me. Okay, uh, so as we see that software as a service have developed the multi-tenancy architecture in such a way that big companies like Zoho, Stripe, Shopify have taken this model and created path-breaking technologies to achieve as many as businesses on a single software. Like, no, as a business owner, just think in yourself as a business owner, you always want that the particular thing which you are being developing should reach to maximum number of people, and maximum number of companies should pay you to use them. So there should be no limit to what you are developing, and no limit in scaling of something. So yes, these companies like Zoho, Stripe, Shopify, if you go and read about their architectures, you would see that multi-tenancy is one thing which has been deep rooted in their core culture of developing a software product. Okay. Yeah.
Yep.
So
Yes.
so the thing which we learned from history was that there were various architectures which we saw in the brief discussion which we did before. There was single organization architecture. Okay? There was single tenant architecture. Suppose if I am an organization like Bank of America, and I just want this piece of software to be mine, not for others, then I can rent this software from IBM instead of purchasing them. So that can be seen as a single tenant architecture. I can sign the NOC thing that no one can, there's an exclusive agreement that IBM just need to rent it to me, non other softwares. There is a single tenant architecture as well. But today, as we have this agenda as multi-tenant architecture, so let's focus on that and move towards that only. Okay, so suppose you are developing an application and you want multi-tenant architecture to be there. So what are tenants? Basically they're renting something, right? So how they're different from users? When I was actually researching this, trying to create one few things to explain, then I was thinking that what's difference between a tenant and a user? Basically, if I'm creating an application, I want multiple users to use that application. That's the whole business logic. So how is different from a tenant application? There's a very subtle line and a very thin line of difference between a tenant and a user. Just let me explain it with a very layman words, which I found to be very interesting. If I am renting a house, okay, then it says that I am the tenant of the house. Okay. And with renting, I am paying rental monthly, like I'm paying 10,000, 15,000 monthly rent for the services which I get. Similarly, if I'm taking, suppose Vodafone services, SIM services, I talk about the mobile SIM services. So I use mobile Geo services or Vodafone services. I pay them 50 rupees, 100 rupees per month for using that service. But in that case, I'm called as a Geo user, a Vodafone user, not a Geo tenant or not a Vodafone tenant. So I found that there is a subtle difference between a user and a tenant. The major thing which I found was that if a tenant uses that thing, if I'm renting this house, obviously with me my family members is also associated, which are actually using that particular piece of property for their needs. But in case of renting a mobile SIM card, it's exclusively for me, not for others. So that's a very thin line between tenant and a user. Understood? I just hope that's very clear, because I
Yes.
don't want you guys to confuse between tenant and user. This is very confusing topic, and I too get confused. But this is very thin line of difference between a tenant and a user. If it's about group of people, a group of family, or if there are people are sharing common things, then they can be seen as a tenant. But if it's exclusively to single person, suppose more brief example, if I give a, suppose Microsoft has created his Word or Google has created Google Docs. So I am using that Google Doc. I am the user of that Google Doc. Maybe I'm paying monthly recurring charges for the Google Doc. Similarly, for this draw application, I'm paying charges for this draw application. But I'm not its tenant, I'm its user. But maybe organization wise, if I see, if suppose OpenXcell as an organization would have purchased this draw application and was paying to the uh, draw company, and I as a user was using that. So maybe in that case we can see that tenant one is the OpenXcell company as a tenant. Okay, so there is very thin line difference between tenant and user, and we need to clearly clear out the differences between them. Okay, yeah. So I'm going at the right speed now. If
Yes,
Yes.
perfect.
yeah.
Perfect. Perfect.
So yeah. So if in this diagram you can show that there is an application which you are developing. It will have your own business logic, your own use cases, your own whole field of software industry would be there, and you have various clients or various customers which you call tenants. Suppose this application is being developed where tenant one would be OpenXcell, other person would be renting this application services could be Google, other services could be Microsoft. Okay, so we will be actually going in horizons, going in horizon of both. Like we will be seeing what happens before this, like application part, and what happens after this part, the above and below part of application. So if I move towards below part of application, let's just zoom in into what's happening in tenant one. Okay, so there is an application and it's being used by tenant one as an OpenXcell, and it has multiple users. Like OpenXcell has Raj as a user, Stephen as a user, Jay as a user. There can be n number of users. Okay, so basically these application services are being used by these users belonging to this tenant. This is one use case of this tenant. Okay, so suppose you are developing an application related to, like, what's your application? Like, is I think attendance management system, right? Basically you're focusing on, if I'm not wrong.
It is an employee management tool.
Yeah, so your employee management tool. So your every organization will have its employees, right? So you can say
Yes.
that OpenXcel has employees Raj, Stephen, and Jay in that tool. So basically your application, in the domains of our applications, will be users, their salaries, their attendance, their leaves. So all these will be the various domains related to this particular application, and each user of this tenant will be associated to those. Like Raj will have its own salary details, own its have its own leaves detail, attendance values. Similarly, Stephen will have his own salary, and so on and so forth. Okay, so this gives that in a single tenant we can also have multiple users, right? So this is what multi-tenant and multi-user architecture look like. Before, it was seen as an application, was seen as a multi-tenant architecture. Then it moved from single, in each and individual tenant we saw multiple users coming up. Okay, just a minute. I just Perfect. So, like, now let's move to what happens in an application to just think about. So, application is just about business logic and data persistent layer. Okay, be it application of 100 lines of code or say 1 billion line of code, be it one repository or 100 repositories, an application will always consist of two core things. It would be a business logic and it would be a data persistent layer. So business logic will be the whole logic and whole business use cases that would be given to you as a software engineer to code, and those use cases would have been come from business development, sales, your product owners, XYZ persons to actually create the software. So this business logic is the need of the software. The code base gets take these needs of the software and converts it to what an machine or a computer understands. Okay, so each and every application in the world has two prominent things: the business logic and the data persistence layer. So why do we need the data persistence layer? Because if we are performing some logic, you don't want that logic, output of the logic, to be lost. Suppose if you are doing some calculations, you need to be saving the salaries, you are calculating the leaves, you are doing any sort of business operations, you need that operation to be safe for future. That's done in the data persistent layer, where we actually connect to databases or have multiple files, use file systems, use cache, any other types of, like, any amount of data persistence layer can have any sort of persistence in them, any way of doing persisting the data. Okay, so as we see that application consists of these prominent two things. Now, as multi-tenant architecture, what can we do to suffice as many as tenants coming up into the system. Like what kind of structure we can follow so that our system becomes scalable. Suppose, you know, maybe in maybe I would say that OpenXL, this has been, you have created a very wonderful system, and suddenly you see that Apple has come and signed you for the particular system. Okay, so your system needs to scale. Oh, Apple has joined the organization, has signed up with you. So obviously your system should scale. So for that, your architecture should be scalable. You have to think what can be done to make this application grow as users grow or shrink as users shrink. Obviously, you have to do cost cutting when needed. Okay. So your in software as a service, or normally when we talk about multi-tenant architecture, the business logic, the code based services, like the code base and the services always remain constant. You try to avoid anything, any business logic or any code base which is for a particular tenant. Suppose you are developing and the employee management system. Okay, so your employee management system would be always independent of which companies it is using, be it OpenXcell, be it Google, be it uh, Apple, Microsoft, or any XYZ company. If needed, like you can do certain customizations or code customization based on certain requirements for a particular tenant. But generally in multi-tenant architecture, the application code, the business logic remains constant, and it is independent of which tenant it is being used. Okay, so when we talk about the architecture, we say that business logic and code based services will be constant, and it will be independent of the tenant being used. So the second part, which becomes as the data persistent layer, this layer is basically whole thing related to particular tenant. This layer will contain each and every data of particular tenant. So what can this be done? How can this be layer be taken into consideration to scale our application, to scale our data layer, and to make our application more multi-tenant and help more and more tenants? Okay, so we will be seeing three different approaches. Okay, how different data persistent layer systems are there for multi-tenant architecture. Okay.
Yes.
Okay, I just hope all are with me.
Yes.
Yes,
Yes. Yes.
Uh,
Yes.
yeah.
yeah. So let's start with the first architecture. It's named as the per tenant database architecture. Like I've just named this. You can assume that for each tenant, we will be having our own database file system, like our own database. So if I say that my code business logic is same, now what can I have is that I have the database for OpenXcell, I have that for Google, I have that for Microsoft. Okay, and suppose I have, like, my application consists of various tables like table, users, sessions. In your case it would be leaves, salaries, holidays, or permissions allowed, XYZ. All the tables or all the domains which you will have will be there here. Okay, so in this we can say that for each and every tenant joining our application, joining our company, we would actually separate its data from one another. We'll have a per tenant database. This is one architecture which is followed by industry in certain circumstances. We will see what are these pros and cons, and later we will try which architecture to choose, like what are the parameters to choose which architecture suits our application. Okay, so before that, if we see properly that there is a code base, there are different databases. So what are the pros and cons of this particular approach if I decide to do a per tenant database? Okay, so basically, if we see that data separation is at its best, the data, the users or the sessions or the leaves you store for OpenXcell user or OpenXcell company will never get matched with the Google company or the Microsoft company. Okay, each and every data source will have its own data there. So if you say that Google employees will be stored here, OpenXcell will be employees will be stored here. So it will be the highest level of data isolation will be provided. Okay, other thing is that per tenant scalability pricing. Suppose you know that OpenXcell is a company of 200 people, right? And Google is a company of say 2 lakh people. Then obviously you want this database to grow larger. and it need to be scale. Like if you are running it this as suppose a 2-core 2 GB RAM, then obviously it won't work with 2-core 2 GB here. So you can say that it would be 8-core 32 GB or 64 GB RAM would be required for Google. But this architecture allows us to scale based on our tenant. If the tenant is Google, we can keep the database instance large and our things are sorted. If the tenant is OpenXcell, we can keep it small. Okay, so that's the whole one of the pros of this architecture. Other very good benefit of this architecture is that if obviously if there is a multi-tenant architecture, these companies are renting my services. So with this architecture, I can have a very good charging model, because I know what kind of services OpenXcell is using, what kind of Google is using, and how much cost of databases or my persistence layer is caused by Google. So it allows me to get a very perfect uh, pricing model. If I can charge OpenXcell less because its services are less, its database instances are run less, whereas I can charge a lot. I can charge a lot to Google as I am running exclusive servers for him. Okay. So this is one of the architecture which industry follows. If I see cons about it, like these were the few pros about it. If I focus more on cons about it, so suppose one of these, I think Inder was name, right? Yeah, Indra was the name. So Indra started saying, okay, I need a new table in this our application, say table underscore leaves. Okay, now what we have to do with that, we have to create that table here, table underscore leaves. Similarly, we have to create table in the other database as well. Okay, so the if any DDL changes, DDL we know that it's domain level changes. Any DDL changes need to be replicated across multiple database instance. Okay, and our code base to work properly, this should be done in sync. If there is anything mismatch, our code base may get errors. So any DDL changes to this type of databases or to this type of architectures are very tough. They had to be done in very spontaneous way, and it's like very tough to maintain the DDL changes on it. Okay, secondly, uh, as a small organization, suppose you are developing this suppose OpenXcell is developing this architecture and this with this architecture, the application. So as we can see that there are multiple database instances. So obviously with each database instance the costing will increase, because database server, there is a minimum cost of spinning up a database server. So for that also the overall costing would increase, not it won't decline, it will increase only. Okay. uh, Third, would I would say that you will have to have large teams to handle this kind of architecture, as there are many like many operations which we need to do. Like we need to maintain that OpenXcell, Google, Microsoft, all databases are up. Any database goes down, we get the alarms. We get any database memory shoot up, we need to handle that. Any database CPU shoot up, we need to handle that. Maximum number of connection errors. So persistent layer has its own various properties associated with that, and with each database increasing, we have to take care of those properties with each database. So if you have n number of database and m number of properties, then you have to handle n cross m properties in your database. Okay, similarly, suppose if I say here if we are seeing only 3 tenants, right? But what if my organization is in a way that it gets 1 million tenants, then 1 million databases, right? It sounds very absurd, right? But yeah, in this architecture, if you choose this architecture, you have to do that, otherwise there is no choice. Okay, for that, let's come to another architecture for the data persistence layer. So it's the single database and table per tenant. So I have my own application DB. Okay, and as I see that there were 2 tables, user and session, what I have done is that I have created tables per tenant. I have created a user table for OpenXcell, a Google user table for Google, a user table for Microsoft, similarly sessions tables, right? So with this, what few complexities definitely got reduced. The overhead of handling multiple DBs got reduced. Okay, so that was one of the pros of this architecture. Okay, again, data separation is still very high because the user of OpenXcell is separated into another entity, the user of Google is separated into another entity, and similarly we go with sessions. So data separation is not just logical, it's also physical. Like in a data, imagine database as a physical book, this will be in on a different page, this would be in a different page. Okay. Yeah. So pricing wise, if I say this was much cheaper than this because you have the single DB instance running on. Okay. So these were a few pros about this. So let's understand few cons about this. So first of all, you have to choose the which table to query for dynamically, which like, okay, so basically I just want to clear that whenever I say table, it can be any table, like it can be, if it's a SQL, if it's a table, if it's no SQL, say MongoDB, it's a collection, if it's DynamoDB, it's their items. So irrespective of which database or which file system you are choosing, the table here refers to the domain. Okay.
Right.
Yeah. So basically now at time of calling from your code base, you need to dynamically select which domain to query. Either you need to query a user for OpenXcell, user for Google, user for Microsoft. Okay, so one con is that you have to dynamically choose which table to query. The second con is same as the upper one. Suppose I need to create one table, then I need to create that table for n number of tenants. If there are n number of tenants in my application, I need to replicate that table for all. Suppose I need to do a schema change for a particular table, then I need to do that schema change for all the different users or all the different tenants they already existing. And I need to make sure that these changes are being reflected with each and every new tenant joining in the application. Okay, so these are very few, these are very serious cons regarding these both architectures. Suppose you have got 1 million tenants, then and you have got 10 tables in your application, 10 domains in your application. So total number of domains or total number of tables you will be handling in an application would be 10 into 1 million. That would be 10 million tables. So yeah, so this way it grows. Okay, the other architecture which I would like to talk about is single DB single instance, single DB single table. So basically what here we do is that we have the application DB, and instead of physically separating the data for multiple tenants, we separate it logically. Okay, so basically we have a table for named tenants table, wherein which we have the table ID names, and suppose tenant ID 1 2 and tenant name and its plan of subscription. Maybe it's paying free, is currently these companies are using the free plan, later they can use paid subscriptions. Okay, and as our application had the table user with them, so maybe we can say that table user. But here what I am doing is that I'm adding a logical operator saying tenant ID, which actually depicts which this user belong to which tenant. So basically this is an identifier. So at every stage you need some identifier. Here the identifier was your database connection, like which database you are querying to, showed which showed which values will it come. If you're querying to using the OpenXcell database connection, you would get data from OpenXcell values. If you're querying from the application DB with user as an OpenXcell table as a identifier, then this table name was your identifier. Here, instead of having table name or database connection, it's the basically a column as an identifier. Okay, so basically I've got a table tenants where I've created tenant one. I've listed down my whole tenants. This is my registry of tenants, simply saying. And table user, suppose the user ID 1 and it's 10 belongs to one tenant, Raj. Again, tenant being organization being 1, OpenXcell, user ID 2, Stephen. 2 means Google, having user ID 1 as Alex. Okay, so with this what we have done is that we have logically separated rather than physically separated. So if I go with the definition that was mentioned below, these instances are logically isolated but physically integrated. So this kind of architecture can be seen that this was physically integrated but logically separated. Okay. Understood?
Yeah.
Yeah.
So let's discuss the pros and cons about this particular architecture which we are seeing right now on our screens. Yeah. So first of all, data separation is its very lowest. Suppose let's talk about the pros first. The pros are that any database changes, any DDL operations are so easy now because you have got just one domain to change. Suppose you need to add a single table, you have got one application DB. Suppose you have to make changes on a single table, no worries, you have got a single table to change for. So database changes are very easy in this case. The maintenance becomes very easy. Third, you have added pure logical separation, like you have added tenant IDs, which actually logically separates each entity from one another. So yeah, so in that case, for management, for development perspective, this architecture is very user friendly and for very developer friendly, I would say. Costing wise also, it's not that heavy. Okay. uh, but obviously there are few cons related to this. As we can see, that table user is a single table, right? And in this single table we have added all the data of all the different tenants. So what will happen in long term? This table would grow very large. This table would be very, very heavy. So in this form of architecture, what cons do we face is that tables going very, very, very large, depending upon what kind of tables are there. Like if you're adding, because at the end what you are doing is that you're accumulating all the data of all the tenants to a particular location, to a particular physical location. Okay. So your table failures can come here, like your tables can get logged. In terms of database terminology, they can, they can stop working. They can be logged, and you can get bounce queries from them. Okay. So that's the one very big con, that your tables can grow large. So the second con is that as tables grow, obviously your queries become slow. Just imagine that you are querying from this database. It would have been so easy that you are querying from table user where user ID belongs to Raj. So it would be like giving OpenXcell Raj. It would be very less amount of data to search for. Similarly, in that here also, as OpenXcell has its own table, it would be very easy to scan and give the result. But here, as the data is accumulated, the queries will become definitely slow. Okay. The third con is the security and data separation. It is the lowest of all. Okay. If someone gets the access to your database, to your table, then irrespective of which organization he belongs to, he can get whole data, from get whole data access. Okay. Basically, if someone got the access of Microsoft DB, then obviously it would have been tough for doing creating Google and OpenXcel. But in this case, as the database and the table name is same, then the security is at lowest level for data separation. Like all the data is integrated with each other, and across organization, across tenants, the data separation is least. Okay. Perfect. Yeah, so we saw this cons of this, but now let's come to what we are using, like what we have been using in Order Hive, and what we are trying to use that in same in the speed is this architecture. Okay. Like I came to conclusion for that, like before hearing you all, just to mention you that why I came to this conclusion was this because as we have seen its cons, there are always the software companies and the software engineers have come up with solutions to solve these cons. Okay. So in later stage we will see that what kind of solutions, what kind of things which we need to do if you are using this type of architecture. Okay.
Okay.
Yeah, before that, as we have seen three different architectures, uh, so it totally depends which architecture to choose. Basically depends on, in my point of view, depends on 2 points. Few points, like these points are number of tenants you have. Suppose as a business application owner, you know that you will have, in next 6 months you are developing in an application, the next 6 months that would have 5,000 tenants. Or suppose you are developing an application specific to banks, and obviously in India there are hardly 100 banks, so you will have 100 tenants. Okay. So the choice of architecture firstly depends on the number of tenants you are going to have. Okay. Secondly, they depend on the expected throughput of each tenant. Suppose you have 1 lakh tenants, but the data for each tenant is very less. They are just, they are very less contributors of your in their application. Your application is not that data intensive per tenant. Then that's again become a very, very crucial formula to understand which architecture to choose. So you have got number of tenants, expected throughput of each tenant, and the third important point is the security. Like if I say that in my application security is the most priority, if I'm developing say application for the navies or the military structure of all different companies, and obviously I would want that the data of one country to be separated from different country. So if data security is my priority, that also comes up which architecture which we choose in this whole process. Okay, so based on these 3 points, I think we can easily categorize which data architecture to choose or which tenant architecture to choose based on these 3 points. Perfect.
Perfect.
Yeah,
Perfect.
yeah.
Perfect.
Yeah. So I mentioned you that these SaaS applications, let's just go back in bit in history before moving to the ways we can solve this cons of this architecture. Okay. As I mentioned that, people very recently users started the SaaS coming up and this multi-tenant architecture. Don't you think that people would in the late 1980s 2000s would have surely thought that why are they developing such softwares which are only for one particular user or one particular company? Maybe the engineers were not that smart at that time. No, I don't think so. They have created so many languages which we are still using, so obviously engineers were very, very smart. Maybe the business people were not thinking big. No, not at all. The business people always wants to acquire more and more customers. So what was the problem if I think about that? That those people were not using this type of architecture in 2000 in 1980s. Like why they were developing such software specific for particular organization. Okay, the biggest hurdle which I think they were doing so was because to the limitation of infrastructure. Okay, as so now we will talk about the role of internet and cloud for this multi-tenant architecture. Okay, so if imagine that you are in 2000s and you are developing such kind of multiple architecture or multi-tenant architecture. So what you want is that your application to scale at every new tenant coming in. Every new tenant comes with its own throughput. So you want that application to scale, and you are handling physical servers at your location. You want that electricity to grow up. You want that server racks to come up, and networking wires, so on and so forth, so many things to actually add service, to give service to every user being added to your organization. Okay, so that was a very big challenge which they people saw, that limitation of infrastructure. Just imagine that what internet has done to us. I currently am running my code in my local server, like my Java server. Okay, and I am connecting to database of hosted at US East 1. Suppose internet would have not been there, so obviously I would have not been able to connect a database of being hosted at US East 1. So that's the revolution internet has brought. They have given us the permission to connect to a very remote database and where it is being hosted. And with cloud, now next, if I move to the second point, with cloud has come enormous number of computing and memory powers. Okay, you can easily spin up an instance and database instance. You can horizontally scale, vertically scale. You can do auto scaling, auto shrinking based on all your requirements. So cloud has bring up with very enormous number of computing power that can be used to create such architectures. Okay, so if I now come to how can we solve the cons of this architecture, the most important thing which will come in mind is your using cloud technologies, using this very new architectures which we have come up to solve these issues. Okay, now the one issue which now I will be focusing on solutions, like if you're trying to use this architecture as a member of speed, we are using this architecture, and I'm very pretty much sure that this same architecture was being used in OutDrive as well. So how we are trying to address the cons of this particular architecture. Okay, so I would start with the first con. It says that the my queries become slow because the data is being concentrated in a single table, and the table goes very big. So my queries become slow. Okay, for that, what can I do? As a software engineer, there are few great techniques to handle that particular thing. We can do indexing. Okay, so whenever you choose a multi-tenant architecture and you choose a database tables like this system, you need to follow indexing. You need to index your code. Okay, if I say I've got this diagram of indexing here, no, I haven't got that. But I hope that as a software engineer, you know what indexing is and how can you take its benefit.
Yes.
Okay, so with indexing, you can solve the problem of slowing the queries to some extent, not perfectly, but obviously to some extent you can make speed up your queries by doing indexing. Okay, second things come is sharding, or sorry, replication. So you can, with cloud, you can easily have multiple database instance of a single DB. So there is a master slave concept. So what does this, that you have, suppose you are performing read queries, so you can read from slave 1, slave 2, slave 3. So with the help of cloud, you can actually replicate your database into multiple instances, and get the power of having serving more and more queries without degrading your performance. Suppose two new clients got added in your application, you saw that your server architecture was facing server downs, you saw instance downs, and you were getting slowing down with queries. No worries, just go and spin up a new server instance for read replica, or just a new replica can serve that values to your clients. So replication can be done. So these are the few points which you can consider while you take this architecture. The other point is sharding. Similar to replication, if you're using MongoDB, in that sharding takes a uh, lot more handful place, where the data is bifurcated based on particular shard, and you can actually horizontally scale your architecture. Okay, so these three ways which I talked about, like indexing, replication, sharding, you can easily solve the problem of slowing your queries by adding data into a particular table to a very large extent. Okay, the other thing which I talked about in the con of this architecture was, my table going very long. For that, we usually have a cleansing mechanism in which we try to identify a few things, few properties via which time to time we can delete the unwanted data from these large tables to keep the length of the tables controlled. Okay, like uh, suppose you are actually, you say that as you are developing the employee management system, and suppose if the employee leaves the company, so obviously you need to delete. If you keep his data, his or her data in the database table, the table would grow long and long. But you decide that you have got this as a cleaning opportunity, and you clean that data. Okay, then the obviously the length of the table will be controlled, the number of records in the table would be controlled, and it won't grow as big as it can. Okay, so for cleaning of data, we can have manual schedulers being run, your own business logic being run. Another thing, very important thing, is that the cascading. Okay, so if we see that I have created a relationship between this tenant table and table user, so with the help of cascading, when I can say that whenever the OpenXcell decides to not use my application, and I delete it from my tenant table, all the data belonging to tenant, be it in the user table, session table, leaves table, any XYZ table, gets deleted. Okay, so for data cleaning and cascading can actually help you achieve keeping your length of the column, length of the table, the size of the table restricted to not going so large. Okay, and the third con which I talked about was of security. So if we think as a business perspective, security is a matter, but there is no particular solution which you can think of to solve the security in this kind of architecture if you choose. So okay, so we have got the three cons, and technically what we can do to solve those cons, I've discussed the approaches. We are doing, like, whenever we create these tables in our application, like currently we have around 7 to 8 tables or domains, whatever you say in our code, and we have started creating indexes from right now onwards only. You can always think of creating indexes whenever you create new table or new collection. Indexes are being created in MongoDB as well. Okay, and any database have indexing strategies. Later in our plan, like, we have started the database as a database cluster itself, being with only one master and one slave. Later we will scale up with to n number of slaves. So these are a few technical things as architectures we can think of and keep in mind while working with this particular mode of architecture of single DB, single table for our application. Perfect.
Yeah.
Perfect.
Yeah.
Yes, perfect.
Yeah. So this was all about this persistent layer. Okay. If we see the brief about the business logic layer, uh, obviously cloud has given another very boom to clustering services. So if I say that I have got this clustering services, our application runs in cluster, and we have got this load balancer. So adding of each organization, if this our application cluster in the number of instances in our application cluster fails to you know fails to supply the demands of the new organization being added, we can obviously scale this. We need to code in such a way that this code is scalable, and we can scale it horizontally as much as possible, try to avoid vertical scaling as much as possible, and uh, you know take this consideration while we are coding and we are developing the application. So obviously, application scaling also remains a particular part in multi takes a very important part in multi-tenant architecture. But the languages and the tools mostly we use today are developed in such a way that they can be scaled at any number of instances. So less to worry in this side, but yeah, definitely a precaution to take that we don't mess up the code. Okay.
Got it.
Okay, okay.
Okay.
Yeah, so I've covered both the parts of application being responsible to serve the multi-tenant architecture layer. I think we are good with this now that we have understood both the terminologies and the ways, if we are trying to achieve this particular tenant architecture, multi-tenant architecture, the ways we need to follow and keep in mind while developing and such application. What are the steps we need to take from right from now and have to keep in mind for later stages. Yeah, so I think my most of the technical things, and like I haven't shown you the code or something, but my most of the brief has been covered. If you have any doubts, or like we can see that now. If you have any few questions regarding that, we can definitely go for that. Otherwise, let's see. Yeah. Any questions? Anything from you, Stephen, or developers?
Yeah, Raj. This is Indra. Just a one question means in this, as we are maintaining multiple tenants, so we'll be having a one master user for creating those tenants, and means basically to perform the CRUD operations, and who will have the master control over the application.
Okay.
So we'll be having such a user like here, as you are showing that we are having tenant one OpenXcell tenant to Google. So there should be a super user who will create OpenXcell one and Google, right?
Yeah. Okay.
So means, yeah, means we have to means maintain such a panel in our application to maintain this thing also. So
Yeah, definitely you can
yeah,
do that. You can
and
create like yes.
yeah, means in our current use case, as we are making this tool for our own organization at present, and so I think the third architecture which you showed, single DB single table, will be a right match for us, right?
Yeah, most of the companies and most of the software which I have seen till now and I've researched upon, I use this only, see,
Oh,
single DB, single table architecture, because they understand what are their business use cases, what kind of tenants are going to come to their system. And as I mentioned that these cons of this architecture are being handled very beautifully with various software solutions, right?
oh,
So most of the companies focus on this only right now, is what I think.
okay,
Yeah.
okay.
Yes, any other doubts or something?
Rajat, you have anything?
We actually explained most of the part. Like I was looking for the architecture which to follow, and among the three, I found which one to use. Like Indra suggested, we'll be going with the third one. So yes, according to you, Raj, when should we use the first architecture? per tenant architecture, per tenant per database, I believe it was.
Yeah, I've seen, like I personally seen the use of this architecture. Suppose you are developing an application for banks, as I mentioned, okay, or
Okay.
for, suppose like in my case, it was being developed for FMCG companies. So you have got very few listed FMCG companies in India, like HUL is there, other company I'm not in, Palmolive is there. So there are very few tenants, and these tenants are massive. Like if you think about HUL as a company, the Sun Unilever, they are massive company. They are a big organization itself. So in that case, the security of their data is very important. Like the companies want that their data is with their database only, not with others. So in that case, they do this kind of stuff where they separate the database, the whole data architecture.
Okay. And okay, if what if our business logic goes down, means are we using the same server for all of these tenants? So what if our own server goes down? So all of the tenants will have to suffer, right?
Yeah, if your own servers go down, then be it tenant multi-tenant application or any kind of application, if your code base or services have gone down, then obviously all of them would suffer.
Then how to means do you take any measures to counter
Yeah,
such
that's
problem?
why I've mentioned that clustering of uh, our code, our own application. With the help of clustering your application, what you can do is that we can run multiple instances of a single application. So the first case is that your single application goes down. Okay, suppose this
Yes.
application goes down. So still you have got two applications to serve. The worst case in this thing is that their whole cluster goes down, and that happens really less, all thanks to cloud services. Okay, and there is something called Kubernetes or ECS services. There are various layers by which this kind of whole infrastructure management is done in a way that if something goes wrong, it comes up within seconds. Suppose if this application got destroyed, and another new application spin up in seconds without any manual intervention. So this technology, this kind of whole mechanisms have been developed. So to answer your question, try to clusterize your application so that you can run multiple instances. Try to develop in such a way that you can run multiple instances and horizontally scale your application. If you're trying to do vertically scale, suppose you have got two tenants and you're running at 4 GB 2 core. Suddenly you saw that four more tenants coming, you're coming in an application, and your whole application getting slow. The other approach you will think of is that why not just from 4 GB take it to 16 GB RAM and from 2 core to 8 core. Okay, but with that there will be always will be one loophole, that if that instance goes down, what's next? But instead of vertically scaling, what would have done is that it would have scaled it horizontally, have kept the instance as 2 core 4 GB RAM, but I would have spinned four instances, and obviously four instances would have served my all request. Then if any of them goes down, still few instances are there which will be serving the request to the particular clients. So yeah,
Getting
the
your point.
horizontally scaling part is there always. Okay.
Yes, that about that sums up all my queries. I don't
Perfect.
think so. I have any of them left. Okay, that is it, sir. That is it.
Perfect. Yep. So yeah, I just hope you would have got some knowledge in this. Stephen, I think I've completed my thing which I've created now.
Sure, Raj. Raj, I just had one suggestion. If you can show something, related to this topic on speed, if you have implemented something, is it possible?
Yeah, the best common practices or the best practices, anything like that, I believe.
Basically, currently we have created the services like the data layer which we have created, like which is related to user management only. Let me see. Let me share, because basically we are following a different kind of tenant architecture. Just a second. I will try see few things from my end, whether that's possible or not. Basically, we are having different kind of a bit different kind of molded architecture of this tenancy. We have account based structure, like we have got multiple accounts for a single user. So it would be a bit confusing, but still let me think, just see one thing whether I can show you.
Yeah, just like the basic, functionality, if we can check with an example, so we can relate to it somewhat.
Just a minute, maybe the call will drop, I just hope.
No, it won't. Jyoti, the
No,
call won't drop, right?
no. Basically, I've connected to the VPN. That's why. Done.
Okay.
Even if it is, we can rejoin again with the same link.
I know it's connected. It just
Even if
dropped.
it is, in case.
Sure.
Okay.
I'm just connecting to my database. I will show you one. Currently, per account, we haven't added anything. Uh, just a second. Let me think. Because currently in speed we are in the development perspective.
No problem, Saj. So if you have anything in future, we can check it out.
Surely, like we will have like the things which we are calling as tenants. We have our accounts for that, and a user belongs to different accounts, and then a single account can have multiple users as well. So that's a molded structure of this part only, like the multi-tenant architecture. This part only. Instead of tenant ID user ID, we are having account ID user ID. Okay, so
Okay.
but the whole development of account section is left, so I won't be able to show more than that.
No problem. So maybe in future, if whenever
Sure,
you
sure.
are ready, we would love to see it so that we can relate it to our product that we are working on.
Perfect. So as a developers, don't forget of indexing, cascading is very important. Relationship, foreign keys. If you are using SQL, obviously, no SQL, then you have the freedom. But cleaning of data, timely cleaning of data, timely indexing of data, uh, then maintaining particular tables with correct schema, not forgetting tenant ID, user ID in every domain you require. These are the few very things you need to consider while developing
Yes, I
using this.
had one more question. How
Sure.
do you clean those unwanted data?
Like currently, here we haven't done till now because we haven't got the data, but I can give you an example of or drive. Okay, so basically what we used to do is that we used to have logs. Okay, logs of
Yes.
every inventory change. Suppose the inventory of particular product was 10, then it changed to 15, then it changed to 20. So it was growing at a very huge scale, because suppose we had around 1,000 users, every user would have 100 or 200 products, and every product day in and day out per second orders were coming. So just imagine the amount of data being changed and the amount of logs getting stored. Okay, then suddenly we realized that okay, these logs are very long, and we saw a few industry standards, and they mentioned that you would be able to, as a user, you would be able to see logs of max 30 days. Okay, the log before that would be lost. Similarly, if I give example of Stripe, currently we are as speed, we are thinking of creating a different type kind of Stripe application. If you know what Stripe is, we were
Yes.
researching more on Stripe. In that also,
Yes.
they have mentioned that if the 30 days, if the logs before 30 days will be not be shown to you, it would be deleted from our system. Okay, so in that, where such business use cases come up, we can write a scheduler which takes the date and time in consideration and delete those records. So it totally depends on your business logic, if whether that table has such kind of business logic. And as a product owner, the person need to think whether I can have such logic to keep the data short or not. That's one of the things. Like we can't just forget and keep adding. If there is a possibility, we need to take care of that, and we need to uh, capitalize on it. Perfect.
Perfect. Okay.
uh, yes, Stephen, I think
Okay, so I think we are massively sorted on this part. Rajat and Indra, are we like sorted? You guys are clear with the concept?
Yes, we're good to go, sir.
Yeah, yes.
Okay. So Raj, we would request like in future, whenever, if we have any query, will it be possible to reach out to you?
sure, I would be available on Skype, Stephen. You can forward the message, or they can directly communicate to me.
Perfect.
Maybe the response could be dependent on the availability,
No
but
problem.
surely would
No
take
problem.
that. Yep.
No problem. Jyoti, I think we can conclude the session.
Okay, great. Thank you so much, Raj, for shelving this time and doing this on a very short notice for all of us. I am sure we all would be benefiting to it. I mean, especially the team, not me. I'm not technical. But Raj, we'll be looking forward to check your availability sooner, so that maximum people can get benefited from your trading session.
Perfect,
Right.
perfect. I would formalize this more. Maybe later we can
Of course,
have
take
a
your whole
conversation.
time. We'll have and for all of us, we have this rest session recorded. So if anybody wants it, I'll share it with Stephen so that it can be passed with everyone
Perfect.
for your future references. Right. All right. Thank you so much. Thank you, team.
Bye.
Thank you so much, Jyoti.
Thank
Thank you,
you.
Raj.